Oh, I need to share the screen. Hello, guys. So I'm gonna share the screen here. Okay, I record this one, but I didn't share the screen. Okay, so I wanna give you some examples, like to review what is a pseudospace. Okay, so remember a pseudospace needs three conditions. Okay, so for a pseudospace, and these are the notes that I put on Blackboard. So you need a subset of Rn is a pseudospace if 0 belongs to the space, if the sum of two elements of the set is also on the set, and if you multiply the element of the set times a constant is also in the set. Okay, so in practice, what does it mean? So in practice, I give you a 1, 1, 2, 3, and 4 subsets of R2. These are subsets of R2. So first condition, 0 belongs to the sets. So 0 belongs here, 0 belongs here, 0 belongs here, 0 belongs here. So in this case, 0 is the vector 0, 0, no? But we usually just say call it 0, like maybe like that, right? So next, we need to check that the sum of two elements of the subset are in the subset. So for example, in number 2, if I choose, let me make it blue. If I get this element plus this element is outside, you see the sum of this vector plus this vector is outside of the blue area. So it's not on the set. So this one is not a pseudospace. If I choose this one with this one and make the sum, this is outside of the blue area. So that's not a subset either. And if I choose this one with this one, the sum is also outside. So it's not a subset either. Okay. However, if I get, so this line over here, this line is just like something like u times, it's a vector, let's say there is u times any lambda. Okay. A line is a vector times a constant. But this plus 0 because it's crossing 0. So if I put that one vector that is, let's say, AU, and I get another vector, let's call it BU, and I make the sum of them, I can factor the U, and it's A plus B, that's a lambda. So that's in the line. So this one satisfies number 2. And if I got any R times a U, it looks like lambda U, right? So that's for this is a pseudospace. So number 1 is the only pseudospace. And there are not many. So now we're gonna do another example. So as I mentioned, I already did this example, but I was not sharing my screen, so I had to do it again. So what I'm gonna do, and I said this is a good example for the exam. It's a very good example for the exam, especially because this is not 3 by 3 or 2 by 2. This is 2 by 3, so it's a little bit more complicated. Okay, you cannot solve this using the inverse matrix. But let's say the first one, U. Is U in the kernel of T, where T of X is defined by AX and A is defined by like that, and U is given by that, and B is given like that. So is U in the kernel of T? So all that you need to do is consider T of U is A of U And this means 1, 3 minus 1, 2, 4, 0 times u, that is minus 2, 1, 1. So that gives me, when I multiply that, that gives me minus 2 plus 3 minus 1. And the other one is minus 4 plus 4 plus 0. That gives me 0, 0. So indeed, u belongs to the kernel of T. Okay? Good. So now let me take a look on the web work that we have. So sorry, I need to sign in. Let me stop the video. Oh, that's fine. I don't wanna do something that stops the video recording or stop sharing my screen. Let me make sure I'm sharing my screen. Yeah. So because I make a mistake in a little bit. So let me go here and here. Okay. So let's take a look at web work to see how our problems look like. So you have a lot of homework. And remember an exam number 3 is going to be this coming week. Oh, sorry, not sure it's gonna work, guys, because what will risk me a hard time. Let's see. When I do it on my iPad, it's not gonna work. No. Okay, so let me stop the video because it might not work. But I will do another video discussing the web work, okay?